We could take a look at things sort of geometrically as we have, and it's all very precise, and we're computing areas and stuff. But there's also a sense of chance that can be introduced, and when we do that, we actually can see probability occurring in a geometrical context, which is pretty cool. Let me look at some examples and have you think about them with me, and you can see what I'm talking about. So suppose that I have a line segment, AD, and it's cut up with B and C, and you can see the various lengths there. And suppose that I'm going to pick a point on that, but entirely at random. So it's just as likely I pick any one point as any other point. Well then, we can take a look at some probability questions that have a geometrical flair. So what's the probability that the point is on the segment BD? So I'm going to pick a point at random from any of these points on this line segment. What's the probability I pick it inside of here? Well, we know how to think about this. If we know the lengths, then we can actually sort of figure it out, because any one point is equally likely. So I look at the lengths and say, well, what proportion of the entire segment is this segment? Well, we can do that by lengths. So the probability would be the length of BD, which is 3 plus 7, or 10, divided by the total length, which is 15. So the probability will equal 10/15, which we can simplify to 2/3. So it's 2/3 chance, so about 66% chance that I'm going to pick in here, which makes sense, because that certainly looks more than half. If I'm going to do it sort of at random, I think that I'd get in here a bit of time. Let's try another example and see if we can figure out some more geometrical probabilities, just for fun. How about the probability that the point is not on the segment CD? So it's not here. Well, let's think about that. The way we can find that probability is to remember the probability that something doesn't happen equals 1 minus the probability that it does happen. So what's the probability that we would land here? Well, 7 out of a total 15. So 7/15. 1 is actually 15/15. If you subtract 7/15, we get 8/15. And so the exact probability would be 8/15 chance that I am not in here. Cool. Let's try one more together, just for fun. The point that we pick at random is on AB or on CD. So is on AB or on CD. Well, if you want to find the probability where we have two events, one or the other, and they're mutually exclusive, which means there's no overlap, then we can just find the probability of one event and add to the probability of the other. So the probability of being here is 5/15, plus the probability of being in here, which is 7/15, and that sum, 5 plus 7, I have a common denominator, is 12/15, which we can simplify. There's a common factor of 3 in the numerator and denominator, to 4/5. So very close to 1, very likely that if I pick a point at random here, without looking at all, completely at random, I would expect that 4 out of 5 times I'm going to be in either here or here, because what's left over is very, very tiny, very, very tiny. Cool.